question is, who is responsible, right? If I'm driving a regular car and I end up, hitting you, I am responsible.
Yeah.
And the law is very clear on this.
Yeah.
It is not the company that made my car, or the company who wrote the software in my car, or anybody else, really. It's me.
Right.
But if it's my AI that drives the car, then who's responsible? Is it me because I own it? Is it the company who made the AI? Is it the company who made the car? Is it somebody else? Regardless of what you might think, the answer is not known, because the law, at least in the United States and in many other countries, has not decided this.
Hey everyone, welcome to AI Trends with Ash. This is Ash Bala, your host. Join me in this series as I chat with industry experts, thought leaders, and professionals to gain insights into how AI is shaping the future of work. Whether you're a high schooler curious about AI in any industry, or a working professional looking to gain more knowledge, this series has something for you. In today's episode, I'm honored to welcome Dr. Patrick Bangert, a seasoned technology executive who wears many hats in the world of AI and data science. He has an intriguing career along with an equally strong background in both academia and the tech industry. His journey in the realm of AI began with groundbreaking research at NASA and Los Alamos National Laboratory, culminating in a PhD from University College London. Transitioning seamlessly into the corporate world, he has held pivotal roles at esteemed organizations like Samsung SDS and Algorithmica. His achievements include reshaping AI teams at Samsung SDS, contracting R&D projects with external partners, and fostering a collaborative culture of innovation and passion across organizations. Beyond his corporate journey, Dr. Bangert is a creative author with several books to his credit, including Optimization for Industrial Problems and Machine Learning and Data Science in the Power Generation Industry. He is also a sought-after public speaker, sharing insights at numerous AI events globally. With his diverse background in academia and leadership in industry, Dr. Bangert brings a wealth of knowledge and experience to the table. So without further ado, Dr. Patrick Bangert, welcome to the show.
Thank you, Ash, for being here, for inviting me. That's really great. That was a mouthful. I hope to bring that down to earth and show that I'm human too.
Great. Yes. Okay, amazing. So we can just jump right into the questions. So my first questions are going to be about your background, as well as what led you to your career. So could you tell us about your career path from your academic pursuit to your transition into the corporate world? Also, how did you navigate through various roles to becoming a leader in the field of AI and data science?
Yeah, good question. So when I was a high schooler, like you guys, I was always really interested in how the world works. My dad had astronomy books lying around the house with, the beautiful pictures of stars and galaxies and planets, and I really wanted to know what was behind that, right? How that came to be. And so naturally, I became interested in physics. I figured out in high school that physics makes mathematics necessary. Mathematics is the language of physics, and so I took those seriously. They were fun to me, believe it or not. And somehow it's cool to hate math, but it's not cool to hate English. I never understood that.
Yeah.
So don't hate math. Trust me on this one. High school level math might be a little bit boring. But if you take that slightly further, it stops being boring very quickly, and actually becomes very exciting. It's the language that the world speaks, right?
Right.
Physics, chemistry, biology is built up on that language. And so I decided to study that at university. I took a physics degree to start out with. I eventually transitioned to the mathematics department, got a PhD there. All in the same vein. I wanted to see what makes the world tick, right? How can I forecast things that happen in the future? So one of the things that we looked at back then is the sun. Every once in a while, has these protuberances where a big mass of solar material gets ejected out of the sun. And if that goes in the direction of Earth, it disturbs our satellites, and that causes a lot of problems. And so we did that for our project. We wanted to forecast when that happens, right? And so that's pretty exciting. It involved lots of physics, lots of experimentation to get data in. And then we had to create models. And what did we use to create models from data? Well, artificial intelligence. And so that's how I met the field of AI back then. Now, this was in the mid 1990s, right, in the dark ages, before everybody had mobile phones and Snapchat and those things.
Right.
But nonetheless, AI existed, and I took that further and further, step by step, creating my own company after I left academia, eventually coming to Samsung, and now at Sears, where I'm responsible at each stage for more and more things, other people, projects, talking to customers. But ultimately, the desire is the same thing, to figure out how stuff works.
Awesome. So, more background. My second question is, so you research in magnetohydrodynamics and its application to the sun's magnetic field, and that's using machine learning and mathematics, right?
Yeah,
So,
that's right. That was what I just described, right?
yeah, yeah.
So the description of the sun's magnetic field and how it sometimes releases these masses, that's magnetohydrodynamics. It's dynamic because it's stuff that happens. It's hydro because the stuff acts like a fluid. So hydro meaning water, right? So it acts as in fluid properties. And magneto is because the energy that drives the whole thing is magnetism.
Very cool. So I was just wondering how you got inspired to pursue this field and how you like got in terms with it and how you found out what it does.
Yeah, that's a really good question. And ultimately, that was really down to people. When I was in high school, I was motivated by my father's astronomy books, like I said, or by my mathematics teacher, who was an extraordinary person. Once I got to university and had a chance to do a PhD, which again is due to humans encouraging me. I met the guy who was going to become my PhD supervisor, and he was working in this field. So, he obviously was enthusiastic about his own field. He, told me all about it. And then I met some of his colleagues. One of his colleagues was Joan Feynman, the sister of Richard Feynman. And then, of course, I couldn't resist. And so I became, the junior member of the team, and we did our work from then.
Very cool. So the next question attempts to deconstruct the term data analytics for high schoolers. So could you give some real world examples to explain data analytics and different types of analytics and why data analytics is a big part of what you do?
Absolutely. Yeah. So data is really anything that you can collect in a sort of structured way.
Right.
Right. In the modern day, with generative AI around, this data could even be a lot of textual documents, a lot of audio recordings, a lot of videos. So YouTube is a lot of data, right, in the form of video. And you can use AI to translate the video into written text, and then you have a more structured form. But oftentimes, what we mean by data in the context of analytics is really tables of numbers. So you might think, when you go and do your online shopping, lots of other people do online shopping too. And so the company has a huge table of who bought what at what time, how much money did they pay for it, did they get a discount, did they pay for it with the credit card or some other way, et cetera, right?
Right.
And you might have millions of rows of people's transactions. And then you want to ask some questions like, what products are most commonly bought? What products are most commonly bought together, right? If I buy, I don't know, milk, then I'm likely to also buy cereal, right?
Right.
Now, I'm likely to do that, which then leads a mathematician like me to ask, well, how likely is it? You
Yeah.
know, Is it a 50% chance that I'm going to buy cereal too? Is it a 75% chance? And now the really interesting question is causality, right? What brought me to the store and made me buy, and what is the additional purchase because I was already there, right? So did I come to you to buy milk? And I was like, oh yeah, I'm going to buy cereal also. Or did I come to you to buy cereal and it's like, oh yeah, I need milk.
Oh, okay.
Now, that matters a lot for the company offering it because if milk is the driver, I'm going to heavily discount that milk and I'm going to make the cereal expensive, right?
Yeah.
So watch out, people. They're going to cheat you. All right. But if cereal is the driver, I'm going to make that cheap and make the milk expensive, right? So I want to know what comes first. And that sort of stuff, right? Patterns of how I behave, what causes what. Those are critical things that I want to know. And the collection of methods, and there are many methods that do stuff like this, are called data analytics. Um, the result of that is usually what's called a dashboard. So on the screen, you then have multiple graphics, like you might have a line chart that shows you how things progress over time. You might have a pie chart, with a round circle with pie pieces cut out saying, this is 30% and that's 10%, going to that. That's
Right.
a dashboard, and that's usually the end result of data analytics.
Very cool. So that was all of my background questions. So great background in those. So my fourth question is more specific, and it is about generative adversarial networks. So how do you think GANs, abbreviated, could be used to create cool new things that we haven't seen before in the future?
Right. So that's a very good question. So let's break that down first. So what's a network? That's a neural network. In other words, it is a series of neurons, just like you have in your brain, except that the computational neurons a little bit different.
Right.
They're connected together, so there are like lines between them that transmit a numerical value, and so they interact with each other. And that's why it's a network. It's a generative network in the sense that of generative AI, that it creates something like a picture, like a piece of audio, or of course, a string of text. And it's adversarial really in a competitive sense, right? So let's say we're on a soccer team, right? You have a soccer team, Ash, and I have a soccer team. And of course, we're rivals, right? We compete, right? So I want to win this game, you want to win this game. So we both train real hard.
Yeah.
And how do we train real hard? Well, we compete. All right. I play soccer games against another team. You play soccer games against another team. That's adversarial. Right. So I get better because I'm trying to beat people, not because they're bad people or anything, right? Just because I'm trying to get better at the sport.
Yeah.
Um, so that's what it means to have an adversarial network. So that requires two networks, one that's trying to become better and one that's trying to beat it, right? So as I'm trying to beat this one learns to become better. And
Interesting.
in that eternal competition, I get better and better and better until one of them wins, so to speak, and
Right.
becomes good enough to do something. So it's a common teaching technique. Of course, this is to some extent how we teach you guys in high school, right?
Yeah.
We don't want to make it into a competition all the time, but let's face it, it is some of the
Yeah.
time.
Yeah.
Right? So you are yourself a generative adversarial network. The network is your brain. The generative is the fact that you have to write out your homework, and the adversarial are your classmates, right?
Right.
Um, but you become a better person, you become a better student, you become better at math and physics and whatever through that, and that's the same way. What can we do with those? Well, as I said, they generally produce either text or video or images, oftentimes images. So if you now go online to any one of the generative websites and you say, I want a picture of myself dressed like a Viking,
Yeah.
right? So it will generate you a picture that looks pretty good. Yeah, you get a nice little helmet with horns and all that looks great, right? So I challenge you to do something like that. Um, that is the result of a GAN, right? So it can produce things of that sort. And so of course it has lots of entertaining purposes like that. They're not useful, but they're entertaining. But we have a whole bunch of use cases where it is actually useful in the sense that it adds to your own productivity. Of course, not quite so interesting for high schoolers because you're supposed to write your own essays,
Yeah.
but generative AI is pretty good at writing an essay for you. Now, don't do this at home,
Right.
but if you tell it, I want a two-page essay that addresses this question, right? It'll do a pretty good job of doing that. Now, it's not a great job, but it's a good start.
Awesome. So my fifth question is more about your past company or former or your company. As the former CEO of Algorithmica, you led teams in modeling projects for predictive maintenance. So can you discuss a specific project where AI models were employed to optimize maintenance schedules as well as the resulting improvements and cost savings?
Great. So predictive maintenance is really about forecasting when machines break down. So we dealt with this primarily in the oil and gas industry and the power generation industry. So those are not necessarily industries that you guys meet every day. But when you plug your laptop into the outlet in the wall, electricity comes to it. That was produced at a power plant. Now, generally, power plants run in the old-fashioned way. You light a fire. The fire heats up water that makes steam, which turns a turbine, which turns a generator, and the generator makes electricity, right? And
Mhm.
so the only real choice you have is how you make the fire, right? Do
Yeah.
you have it with oil, with coal, with gas, with nuclear fuel, making it a nuclear power plant, right? Those are the basic choices.
Right.
Uh, so the thing that turns the turbine and the generator, they turn. They're very large machines. These are machines the size of your house, and they turn. So you can imagine that every once in a while they kind of get damaged and they break down, and that's maintenance, right? So predictive maintenance is forecasting when those things need to be maintained, when you need to stop them, right? You need to open them up and you need to go in and find the problem. Now, the problem might be, just an inch in size in a machine the size of your house. So you can imagine that sometimes maintenance takes a long time just to find the damn thing and to repair it, all that. And during that time, of course, you're not producing any power, which means that the people trying to charge their laptop are unhappy,
Yeah.
right? So predictive maintenance, therefore, is a big problem,
Right.
right? You need to know in advance. You need to plan. You need to buy the spare parts. So that's what we were trying to do there. And turbines are also very expensive. They might cost you 300 million a piece. You have to order them 2 years before you get them and things of that nature, right? So you really don't want them to fail.
Yeah.
The other thing is that a lot of this stuff being so large, when it does fail catastrophically, it generally kills people along the way, right?
Yeah.
Things explode, stuff flies around, people get hurt, right? So you really don't want that.
Of
So
course.
that was one of the major applications that we created at my prior company to do that. And this is an example, right? We forecasted the failures of turbines, of pumps, of compressors. Compressors are the opposite of turbines, right? They take in air and make it more dense, like
Yeah.
in scuba diving gear.
Right. Right. Right.
You have compacted air, right? All sorts of things of that nature we forecasted failures on.
Okay, great. So my sixth question basically is about the European Union passing the AI Act. So, in response to this, you'd mentioned on your LinkedIn that knowing what is allowed versus forbidden is an essential aspect in generating trust in any industry. So, could you please elaborate on this and for the benefit of the high school audience?
Yeah, absolutely. So it is an absolutely landmark event
Right.
that the European Union passed this act. It's the first jurisdiction, first major jurisdiction in the world to
Yeah.
do that. Um, there are other legislations that are currently on the table from countries like Russia and China, although we have to ask ourselves to some extent whether those will be enforced or at least will be enforced equally
Yeah.
for all actors. Other countries are working on this legislation. In the United States, we've had an executive order by President Biden recently to that effect. That is not, however, law passed by Congress. It is just just in quotes, an executive order by the president, and it doesn't have penalties, right? Which is really the major element. So, if you don't do what President Biden asks you to do, there is no penalty to that, right? So that leads us to ask to what extent that really is binding.
Right.
So it's effectively at the level of pretty please would you, kind
Yeah.
of a level. Whereas the Europeans are, if you don't, you will be fined in
Yeah.
certain circumstances, and in certain other circumstances, you're going to prison. So it's a much more serious law along the lines of every other law that we know.
Yeah.
Um, Now, you will use AI in various circumstances in your life. Now, obviously, you going to Netflix and it recommends certain movies, that's AI. You go to Amazon and it tells, people bought this, that's AI too.
Yeah.
Now, is that harmful to you? Probably not so much.
Right.
Then you go to Instagram and it shows you, ideal body type images, and then you start feeling bad about yourself. That's AI, and it is harmful to you.
Yeah.
Um, right? So, in case you get exposed to stuff like that, you need to take a step back and kind of rationalize that normal people don't look like that. There is no pressure on me to look like that, right? They are harming me, so kind of shut it off and let it go.
Right.
That is now offensive in Europe. It is not in the United States, right? So there's a difference of opinion on whether things like this ought to be permitted or not.
Right.
We can debate the extent of harm. Let's take it to an extreme level. Autonomous driving, right? Cars driving without human drivers around the road. They
Yeah.
occasionally make mistakes. It has led to people dying before. Those occasions are rare, admittedly, but they did happen. They do happen. Question is, who is responsible, right? If I'm driving a regular car and I end up, hitting you,
Mhm.
I am responsible.
Yeah.
And the law is very clear on this.
Yeah.
It is not the company that made my car, or the company who wrote the software in my car, or anybody else, really. It's me.
Right.
But if it's my AI that drives the car, then who's responsible? Is it me because I own it? Is it the company who made the AI? Is it the company who made the car? Is it somebody else? Um, and regardless of what you might think, the answer is not known because the law, at least in the United States and in many other countries, has not decided this.
Yeah, that's where it gets like ethical and sticky, where you have to determine who's at the wrong in that situation. Yeah, sorry.
Yes, yes, absolutely. And so it's so important for countries and states to make up their mind because uncertainty is even more harmful than knowing that you're liable.
Right. Yeah.
Uh,
Awesome. So, just like as a quick follow-up question, what do you think the government can do to enforce AI rules? Because, AI and generative AI is a very fast evolving thing in this era. So, I was just wondering what you think the government can do to enforce these things.
Yeah, that's a really really good and deep question. So I mean, first of course, they need to have clear rules to enforce.
Yeah.
Currently, the rules don't exist, so it's kind of hard to enforce rules that you don't have.
Right.
So that would be the first step. Um, the second step is that you would need experts in the technology to be able to determine whether or not a rule has been broken or not.
Right.
Um, and that's difficult because it's highly technological. With a lot of our other rules, against things like fraud or murder or whatnot, it's not too difficult to decide, whether it's happened. But for AI, it's a little bit trickier. You need technologists available, and that's a tricky thing.
Yeah.
Um, so you need to assemble the right team of people. You need to give them the resources, particularly the resource of time, to be able to study this carefully and do it. And all that doesn't exist. So for the US in particular, I would say, first of all, we need to create those laws like the EU AI Act. And secondly, we need to create an agency that is responsible for enforcing those.
Right.
Um, like for food, we have the FDA, the Federal Drug Administration, right? That regulates whether or not a certain kind of food can be sold and eaten by us, right? And it occasionally changes its mind.
Right. Yeah. So my next question basically leads more further into what we were talking about ethics. So ethics plays a crucial role in the development of AI technologies. Sometimes ethics and law don't align, like you mentioned previously. But separate from regulations, how do you think academia and AI companies should approach defining right and wrong?
That's a deep question.
Yeah.
Yeah, I mean, this is a very important question, I think, of these days. So I think the first thing is that companies need to be aware that they do need to approach it.
Right.
I think most companies up until the present moment have more or less ignored this and said, well, that's not our job, right? Our job's to make money. It's the government's job to look after the right and wrong.
Yeah.
So it's been very recently, really, that it's on the company's radar that they need to do this. So the first thing I think to make clear is what you think is ethical and unethical. Of course, many people have a very differing view on this, and if you start reading books around ethics, you start discovering that people have wildly differing opinions on, except for the extreme cases, of course, but very different opinions about what is ethical and not. Um, so coming to an agreement on what it is and being able to state that in public, like, these are our ethics principles. This is how we've defined it. That would already be an excellent start.
Yeah.
And then, of course, again, you have to have people, staff in your company that enforces this, which
Yeah.
means it's going to cost you money. Of course, that's something companies often don't want to do, is to fund initiatives like this.
Yeah.
But that would be the necessary step. And there are frameworks that allow you to do that. So I wrote a framework for ethical AI that we adopted at Samsung. It's on my LinkedIn. Everybody can look it up. It's fairly self-explanatory. Um, but I think this is really a very important step for the future.
Yeah. And just as a follow-up again, do you think humanity as a whole will, determine what is wrong and right ethically, like ever? Or do you think it's always going to be like a gray area?
It's always going to be a gray area, I think.
Yeah.
Yeah, yeah. So different people have different views. So obviously, most of the conversation these days is based on the Western tradition, right? The tradition that ultimately started in Greece a couple thousand years ago. That influences the trail of thought that ultimately went to Europe, which came to America, and that's what we talk about. But there are other traditions, right? Africa has a very solid tradition of this Ubuntu philosophy and several others related to it, which is a much more relationship-based idea of ethics. Um, then I'm a practicing Buddhist, so we have Far Eastern traditions coming out of India and China and so on that again have a very, very different
Yeah.
view on what is ethical, a much more long-term view, right? If you think about reincarnation.
Yeah.
Um, and they are to some extent at conflict. with the Greek tradition, but
Yeah,
those discussions are
definitely.
not even being had
Right.
by the technology companies. Of course, the majority of technology companies are where we both live in California, and so it's far away from those places, both culturally and geographically. So I
Definitely.
think we have a long, long way to go, and I think there will always be plenty of gray areas to have to think about.
Great, great. So my next question is, so the workplace landscape is seeing very interesting and groundbreaking changes every day. There is an explosion of innovation across all domains, from Sora, the text to video platform, to Groot, a general purpose foundation model for humanoid robots, developed by NVIDIA. How do you think high schoolers and college grads can prepare for a career in this, AI in flex landscape?
I think high schoolers are really well placed to take advantage of all this.
Yeah,
It is literally at your fingertips,
right.
right? You have a laptop or a tablet, that is all you need.
Yeah, compared to
Um,
like many years ago. But yeah, definitely.
yeah, yeah. I mean, it is essentially free of charge once you have the basics like a laptop. It just costs you time. Now, of course, I know from having a couple of high schoolers at home that having time is something that is at a premium for
Yeah,
all of you. Um, but it is worthwhile if you're interested in STEM type topics. AI is a really good thing to get into and to experiment with. You can do that purely on your laptop, like with the tools you mentioned, and there are dozens and dozens more that you can do. Or you can do it to some extent physically. So, for instance, about 4 or 5 years ago, NASA publicly released the design of the Mars rover.
right. Yeah.
So you can buy for relatively okay amounts of money all the components you need to build your very own Mars rover at home.
Yeah.
And you can assemble all of it yourself. It's all available on the normal market. And then you can have an autonomously driving vehicle of your very own inside your own house and backyard. And it has a compute engine, based on a Raspberry Pi, where you can upload your very own AI models that help that robot move around, do things, right? It has a grappling arm.
Yeah.
It can recognize objects through its camera, like, hey, this is a rabbit or whatever,
Yeah.
um, and then take the appropriate actions that you want it to take. And you can, of course, use tools like Groot, etc., to make things like that happen, to create your own interactivity, and it is really awesome for you to experiment with. And I'm sure if you have a technically minded dad or mom at home, a project like this with their very own high schooler in the house would be a super cool family activity
Completely
that
agree.
I really recommend to all of you guys to look after.
Awesome. Yeah, and I think it's really important that you brought up a lot of high schoolers have a lot of opportunities with AI. I know my school provides, Chromebooks and laptops because of the fact that so many assignments are online. I think it's also important that high schoolers know how to mitigate AI and computer usage, because a lot of people use ChatGPT for work, which is not the right way to use AI in anyway. So I think it's important that you brought that up. So my next and final question is a question that I often ask on this podcast. So there's often talk about the potential risks of AI, including concerns about an AI apocalypse. What is your definition of an AI apocalypse, and how do you think it could be, or it could not be something in the future?
Right. I watch Hollywood movies just like the next guy.
Yeah,
I've seen the Terminator series and all the other various AI movies. They're a
yeah,
lot of fun to watch. They're good entertainment, but they are not realistic. We are extremely far away as an AI community from that kind of a thing happening. It's so far away that to me it is unimaginable even how we would do it, even if we wanted to.
Right.
If you guys will play around with ChatGPT and Co. for just 5 or 10 minutes, you'll discover how extremely limited they are in their understanding of the world. It is completely obvious that they do things by rote learning rather than actual understanding, right? They don't know how stuff works. They don't know how people interact. The things that they talk about, they don't know what they talk about. They can simply put words together in a statistically likely way. So until the point where logical reasoning and causal reasoning of if I do this first, then that will result, right? If I push something until it falls and then it will fall and then it will break when it hits the ground, right? That kind of causal reasoning that to us is a triviality, right? These models don't have that. They're not aware of that.
Right.
Um, so they would not be able to plan actions and carry them out and things of that nature. Also, robotics, the actual translation of these digital information into real life physical actions is very, very much behind the times on this.
Yeah.
So even if we had an AI that wanted to act on stuff, it wouldn't really be able to that extent. And while there are a couple of people that I know who are researching at university level how to put logical and causal reasoning into AI, the companies that the Googles and Metas and so on of the world, they're not looking into this. Why not? Because they're not interested in making artificial general intelligence. They're interested in earning money. And the stuff that they did, with ChatGPT, and so it has the potential, I should say, it has the potential of making a great deal of money. And I promise you that they'll be busy for 5 to 10 years from now, just in the process of making money on the back of that kind of stuff. We're not actively pursuing any kind of general intelligence. So I don't expect to see anything close to that in my lifetime. So I'm not afraid of Hollywood movies. They're just entertainment.
Great. So that brought us to our final question of the show. Before we sign off, Dr. Bangert, do you have any final thoughts for our audience or extra advice for our high school community?
Yeah, I'm really excited to speak with you, to address you guys as a high school audience. I can just tell you that AI is exciting. The topics connected to it, namely mathematics, namely computer science, robotics, they're also very exciting. They offer you a great path in your education at university, and of course, a great path in your career. If you're in the Silicon Valley, you know that already, but if you live outside, yeah, there's a serious career path available. That is not going anywhere. Even though people talk about layoffs and stuff like that recently, that's just a temporary blip. So pursue it, have fun while you're doing it, but don't forget that things off the screen are also interesting, and people are interesting, and it's particularly great to interact with people in 3 dimensions. So
Yeah.
if you can, I would really, really encourage you to pursue AI topics together as a group. Get together in the same room, work out stuff together as a team so that you don't learn just AI, but you learn how to work together with others. You learn how to be a team player. That is really, really useful. And the most useful of all is communication.
Right.
If you cannot express what you've done and listen to other people express what they've done, then all of this is useless anyway. So that's my recommendation to you. I thank you, Ash, for inviting me.
Awesome. Thank you so much, Dr. Bangert, for joining me today. It's been an absolute honor having you on the show. So, with that, we wrap up this episode with Patrick Bangert, a trailblazer at the intersection of AI and data science. I will see you all in my next episode. Until then, stay curious. Bye.